All right, you found the quick review of solving motion problems with systems, and I'll try to be quick. So let's get right to it. Car leaves Orlando at 8 a.m. heading north. Another car leaves at 1 p.m. heading south and averages 5 miles an hour less, so I'm reading as I go, than the first car. How fast was the second car going if they end up 1,211 miles apart at 7 p.m.? Seems impossible, right? Well, it's not. As you recall, started all off with the formula. So you look at this and say, hey, what's the motion formula? It's rate times time equals distance. Maybe you learned that distance equals rate times time. I flip it because it helps my chart. All right, so I know I'm going to have a rate column. I'm going to have a time column. I'm going to have an equal column. I like that. I'm going to have a distance column. Okay, so there's our chart. And then remember, you want to label your rows. What are your rows? Well, I'm going to call the first row the first car. I could have also called it the northbound car. I'm going to call the second row the second car, or I could have called it the south car. Okay, what do you fill in first in your chart? I always tell you to fill in the variable column first. So what are we looking for? How fast was the second car going? We're looking for a rate. We don't know the rate of either car, so we're going to call the rate of the first car X and the rate of the second car Y, and we're going to solve this as a system of equations. Okay, now I got to look at the problem and try to find time or distance. All right, with time, I'm told the first car left at 8 a.m. and stopped at 7 p.m. I have to add that up. That's 11 hours. 11 for the time of the first car. Second car started at 1 p.m., ended at 7. That's 6 hours. Okay. Now, how do I get the distance? The only thing about distance in the problem is 1,211 miles, and that's how far apart they are. So that's the car going north plus the car going south. So that's not either car, that's both of them together. So how do I get the distance of the first car? I multiply the rate times the time. The rate of the first car, so I take the rate of the first car times the time of the first car, and I get 11x. And I do the same thing for the second car. The rate of the first car, y, times the time of the second car, 6, gives me 6y. Great. I've got my chart done. I'm getting there. Now I've got to get my two equations. Well, remember, your equations come from the columns with the variables. So I'm going to have a rate equation. So let's figure out the rate equation. All right, and remember, I told you the rate equation will either be a total or it'll be a comparison. You have to figure that out from the problem. Go to the problem and look. All right, it says here in this third line, the car goes south and averages 5 miles an hour less than the first car. Well, that's a comparison. They're comparing the first and the second. They're not telling you how fast it's going. They're just saying it's 5 miles an hour less. That's a comparison. All right, remember the template for comparison is always the first equals the second. In our case, the first is the first car and the second is the second car. Now remember, we're talking about the rate. What's the rate of the first car? Look in your chart. The rate of the first car is X, so I put in X. What's the rate of the second car? Look in your chart. It's Y, so I put in Y. Now here's the other thing. I have to deal with the comparison factor to make it an equation that's equal. Well, it said that this is going 5 miles per hour less. So how do I make them equal? I've got to add 5. That's an ugly looking plus. I've got to add 5 to this side. Now, some of you have trouble with that. So I told you, hey, just come up with a miles per hour. Let's say the first car was going 85. Well, then you'd know the second was going 5 less than 80. How do you make the equation equal? Add 5 to the 80, right? And it's pretty clear then if you just do your own numbers, all right? But you got to put that 5 in the right spot, and so 5 miles an hour less. Okay, so that's the first equation. Second equation is going to be the distance equation because that's the column with the variables. So distance equation, again, is it a total or a comparison? Look at the problem. 1,200 miles apart. That's the first car's distance plus the second car's distance. That's a total. And again, a total equation is always the first distance plus the second distance equals the total distance. What is the first distance? Well, look in your chart. It's 11x. So that's what we're sticking in there, 11x. What's the second car's distance? Look in your chart. It's 6y. And the problem says the total was 1,211 miles. Okay, There we are. We're ready to solve. Now, are you going to solve by substitution or elimination? Well, this first equation's all set up for substitution. So I would take x equals y plus 5, and I would sub in the y plus 5 in for the x of the first equation, right? And now I'm going to solve this equation. And for time's sake, I won't solve it all out. I will distribute, get 11y plus 55. And when I'm all said and done, I'm going to get y equals 68. Now, what in the world does this mean? Y equals 68. Go to your charts. Oh, there's my y. It's the rate of what? The second car. Oh, the second car is going 68 miles an hour. What did the question want to know? How fast was the second car going? Oh, I'm done. 68 miles an hour. All right. Quick review, solving motion problems.